everybody. I'm Jeff Smick. I'm here to talk about Zipkin. This is my contact information if you ever need to get a hold of me for whatever reason. Super Squish and Jeff at Twitter. Pretty simple. I'm just going to kind of jump right in. So we'll start with what Zipkin is. It's a distributed tracing system, and it's based on Google's Dapper paper. If you haven't read it, go read it. It's a pretty short paper. It's pretty simple, and it's really good. Kind of describes exactly what we're doing with Zipkin. So specifically what Zipkin is it's sort of very detailed structured logging for individual requests. So most of you probably run a service. You probably have some sort of metrics. You probably export those metrics to something that can ingest them and show you an aggregate view of what your service is doing. This gives you a very specific view of what a single request is doing within your system. So you also get a full view of the request path through your service-oriented architecture. For instance, we have hundreds of services here at Twitter. A single request coming into the service will go through a lot of them. So with Zipkin, you can actually see how it goes through that, through all those services. It's built directly into Finagle. So if you're using Finagle, you get it for free. And you can add your own information to it pretty quickly, pretty easily. So that gives you extra information. For example, if you're running on the JVM, you can see like, oh, during this request, I GC'd. And you can annotate that and see that in the trace. Kind of what I was saying before, most metrics, they can show you sort of the tail of your latency distribution, but they can't really tell you why. Like, why is my tail so long? Why are these requests getting so slow? They just give you sort of an overall service behavior. So with Zipkin, you can see the latency of a single request. You get the structured log with request-specific information. You get the beginning of the request when it comes into your system and the end of it when it goes out. And then, like I said, you get these service-specific things. So for instance, let's say you are hitting caches and getting results back, and you happen to miss the cache, and then you have to go back to your database. You can annotate that you missed the cache, or you can annotate that you hit. And then you have a better idea of like, okay, my requests are getting slower because I'm getting a lot of cache misses. Again, you can show the request through the architecture. We do a lot of parallelism in here at Twitter. So if we have to fetch, say, 100 tweets, for the most part, we can fetch 100 of them in parallel. But say we screw up the programming model and all of a sudden we're fetching them in serial. That's kind of hard to see if you're just looking at the code or if you're just looking at metrics. But when you see it laid out in Zipkin, you get this really nice stair-step pattern that shows you, oh, I'm doing this in serial, and I could do it in parallel and get it all in one straight line. So we'll jump right into kind of how it works. It's fairly simple, fairly straightforward. There are 4 key events that happen. You get the server receive and server send events, and client send, client receive events. Each event has these 7 specific attributes associated with them. The name, so for most things, it's server send, server receive, client receive, which are abbreviated SRSS, CSS, CR. You get the trace ID, which is a unique ID that identifies that single trace. For Zipkin, that's a 64-bit long in the JVM, so it's 64 bits of just randomness, basically. What we're pushing right now, those collide like once every few days. So for the most part, it's pretty solid. You get a span ID. So in Zipkin, you'll kind of see this in a little bit, but for each part of the system, each part of the system is represented as a span. And so there's a unique ID that identifies that part of the trace. The parent ID tells you tells you the parent of that span. So if your service gets a request in and then makes a request, that next request is the child of the first one, right? Because that's the service is making the request. So now you can start to assemble this hierarchy of events. We have a flags field, which right now we very sparingly use. We just say whether or not it's a debug event. Because if it's debug, we make sure that we collect all the information on it and get it stored so that you can see it. We set whether or not we want to trace this request. So in the system, the first service to see a request will decide whether or not they're going to trace that request, and then they'll send that information along with all the tracing information to all the other services. So that way we can sort of downsample, so we're not tracing every single request, because it's obviously like the number of requests we get, we would completely flood the network, would never work. And then a timestamp, obviously, like when the event occurred, and that helps us sort of build that latency graph. And then the endpoint. So if this is a server event, this is the machine that that event occurred at. And if it's a client event, it's the machine that we're trying to send the request to. So that helps us kind of build the graph again. So visualizing this, if we look at the two parallel lines, time goes from top to bottom. The two parallel lines are two different services. The top arrow is showing us a request coming in, and then SR is server received. The 3-tuple or the 3-tuple is trace ID, span ID, and parent ID. So you can see the trace ID is 1, the span ID is 1A, and there's no parent. This is the very first request coming into the system. And then our service makes a client request to another server. So in this case, that service sends a client send event with the same trace ID. It creates a new span ID and sets the parent ID to the previous one. Right, so if we, I don't know how you're going to see this on that, but if you kind of look at it this way, these are spans. This kind of area in between here are the spans, right? So then the next service will get that information as part of the request package. We've sort of, it's easy to build into HTTP because you just add headers. In Thrift, we've sort of built our own version of like Thrift headers on top of that so we can send this tracing information. With Mux, it's built into Mux. So the server receive event has the exact same information as the client sends, so now we can match those two up. And then you get server send on the bottom. It's saying I'm replying to this request. And then the first service gets client receive saying I received this request, and then server send again, right? Slightly more complicated if we're making more requests down sort of down the graph and in parallel. I'm not going to walk through this because you can get the slides afterwards and kind of check it out. But hopefully the coloring kind of shows you that the parent spans cross span IDs. So you can see like this right here would be one span, and its parent is still this span, and this would be a second span with this parent, right? And you can kind of see that in the coloring. I'll let you check it out in detail. So this is Zipkin. This is the Zipkin UI. It's just like junk data. There's a little plugin in Zipkin that lets you generate random traces. So you can see here that this is a list of all our services, and then the span names associated with those. So for instance, in HTTP, you have your HTTP service, and then the span names in that would be something like get, post, delete, right? The sort of general HTTP headers. And then you decide what you want to get, and then find traces. This will usually be a longer list, but again, this is generated data. And this gives you kind of a quick overview. There are 16 spans in this, so there's 16 separate requests in this. It took 83 milliseconds to complete the entire trace. And these are all the different services it touched and how many times it touched it. So you can see it hit this service twice, and most of the other ones just once. And then if you click through to it, you get this kind of hierarchy of it. The little overview, all the services. So this lets you kind of filter by service. So show me everything that hit these different services. Or if you kind of expand it all, you can see what this trace looks like. And then if you kind of click into it, you get an overview of what is happening in that specific span. So this kind of goes and displays a little bit of the extra data that you can add to a trace. So in my service, we're adding these key value pairs. These are strings and then almost any kind of data that you want in here. We have a project right now that's going to add JVM-specific information in here, so you can see when a thread is kind of thrashing around and how much CPU it's taking and all that. And that's kind of the core of it. It's a very simple interface, I think. And you can kind of, oh, I don't know what this, yeah, you can kind of collapse these and expand these. Yeah. So the dots, he's asking what these little dots are. These dots are specific annotations. So there are two types of annotations. We'll go back into this. There are two types. There's the key value type, and then there are sort of evented timestamped annotations. And this is saying, at this point in time of the request, this thing happened. Going back to the sort of memcached idea, this would be like cache miss, cache hit, and you can see exactly when that happened. So that gives you kind of a quick overview of like, oh, some strange events maybe happened in here. If this were a real service, you might see like a little circle and then right under it the next request. And probably those are probably correlated. So this was generated with the Zipkin example project. Zipkin's all up on GitHub. It's almost entirely open source. There are a couple of very small components that are internal only, and that's only because we have a storage system here that is not open source. So we can't send that out. But it's really easy to get started. You just clone it, cd into the directory, run the example, and then pop open your localhost. If you want to see all the flags, so I'm kind of jumping ahead a tiny bit, but how many of you guys have seen Twitter server at all? Show of hands, a little bit, yeah. Twitter server is our kind of version of app, of like Scala's app. It's this really nice main that has configuration flag parsing built into it and an administration service built into it. So you can see, you can get kind of a nice little view of your metrics and various other things, server info. But one of the other nice things is that you can run this little help flag, and it'll take all the flags that it knows about and spit them out to the console and tell you what they're called and mostly what they're like, what their descriptions are. There. So it's a lot, but you can see like Zipkin has a ton of them because everything's kind of pluggable, everything's very modular, and everything just uses these little flags. And you can set any of these different flags for whatever you need. There's like, yeah, the port that you want to listen on is up here, the database that you want to use. So this uses ANORMDB, so you can use like SQLite, or you can use Postgres, or you can use MySQL, and on and on and on. Okay. So the all-in-one just like by itself uses the Scribe collector, and I'll kind of describe these in a second. It uses the Scribe collector. It uses SQLite in memory for storage, so it's totally ephemeral. And it has a web UI, and then you can start it with this random example data, which is exactly what I showed you. So you can start there and then kind of split it out and change it around as you see fit. To customize it, we have a few modules kind of already in the Zipkin project. For receivers, we have Scribe and Kafka. Scribe speaks, obviously, the Scribe protocol and uses serialized thrift structures. Kafka is the same way. It can read off of a Kafka queue, and it reads serialized thrift structures. So your architecture would, your services would send into the Scribe or the Kafka queues, and then Zipkin would read them in. For storage backends, we have SQL, Cassandra, HBase, and Redis right now. There was just a contribution for Mongo. And then for configuration, like we use Twitter server, which you should totally check out because it's pretty cool. It has the config flags in the admin interface, which make it really nice and easy to use. So this is hard to see if you're back there, probably. But this is what I just ran. Like, this is what it looks like. This is the code to run that example script. And you can see on it that we mix in a lot of different little factories that caked it all up. And then we've created our own flag. The third line down is a new flag. That's what it looks like to create your own flags. And then we define a main, and we run a bunch of stuff in it, and then we wait for it to exit. And that's it. So internally, Zipkin's architecture looks a little more like this. You have thousands of services. They're all sending their information into Scribe. There's a pool of Zipkin collectors that read from those queues, send it into some sort of storage backend. For us, it's Manhattan. You may have read about it. And then we have a pool of query servers, and then a pool of web UIs that hit the query servers hit the storage engine. So breaking out that one kind of monolithic main kind of looks a little like this. So this is just the collector part. And you can see what we're doing is we're creating this collector main. We're adding a queue in front of it. We're sending into Cassandra. We're going to use Zookeeper to register ourselves. And we're going to read from Scribe. And then we just define these two receiver and span store methods, and then glue it all together in main. The query server looks very similar, only it's even smaller, because all it has to do is read from the storage engine and present a thrift interface. But the same thing, right? There's new, so in this case, again, we're reading from Cassandra. We're spinning up a server, or a query server. And the web UI gets even simpler. It's already there. It already exists. You just run main. Totally fine. And like I showed you in the flags, you can sort of set where that's listening. You can set the destination of the query server that you want to read from. If you're trying to run this in production, you need to set cache resources so that it pulls all those things into the jar and then into memory, and then also all the static assets are served right out of memory. That's it. Fairly simple, fairly straightforward to kind of get these plugged together. Getting data into Zipkin, kind of like I said before. Right now, it's all serialized thrift structures. There's an idea to do like a JSON ingester or a JSON receiver, so you could just send it JSON, or whatever else. As long as on the other end, you can see the trait write span store extends seek of span to future unit. That's all you need to store data into Zipkin. So whatever you have, like whatever format you want to send to Zipkin, as long as you can convert it into a span or a sequence of spans, you're golden. So we receive data via the collector, convert it to a sequence of spans, and then send that to the span store. So like I said, Zipkin's built into Finagle. It's really easy to get it running. If you're using the new Finagle APIs, all you have to do is depend on Finagle Zipkin, and it's there, it's done. All the core events are handled automatically, so server send, server receive, client send, client receive, those all happen automatically. You don't have to do anything about those. And then you can add your own annotations using this trace record. And there are a bunch of different versions of trace record. You can look inside of Finagle. You can look inside of Finagle core at the trace object, and that'll kind of show you all the methods that you can call. And then it provides these global flags that you can then set via Twitter server. So other contributions for Zipkin, just search GitHub for Zipkin. Somebody wrote something for Akka. I saw Clojure, Rails, Node, Twisted, PHP. I'm sure there are others. Like I said, there's a Mongo one out there. And then I'm the only person working on Zipkin right now, like internally. So there's a lot to do, and I'm trying to get better documentation. I'm trying to get better examples and all that, but I have a lot to do. So if you want to help, I'd be more than happy to have your help. In the future, I'd like to kind of publish this as a library. It's basically already a library now anyway. In fact, the way that we use it internally is there are a couple of implementations of the server that have some very Twitter-specific like logging and things like that built into it. And then Zipkin itself is kind of a library that we pull into that. That's pretty straightforward. Again, better documentation. And then there are these sort of plans to do a more real-time UI. So potentially, you could see traces coming in real time and filter on them in real time. Again, I'm the only guy working on this, so that's far down the road. Unless you want to help. And if you do want to help, here's how you get in touch. The Zipkin project on GitHub, obviously, @Zipkin project is the Twitter handle. We have Zipkin users, which is for just users, Zipkin dev, so if you're a developer and you want to help with Zipkin. And then help me, I want your help. I'm Jeff at Twitter. Thanks. Any questions? So the question was, Zipkin's already built into Finagle. We obviously don't trace every single request, so what number do we trace? By default, that's set at 1 in 1,000 requests. You can modify that number. On smaller services, I've set that to just 1, and then everything is traced. But yeah, that's kind of in there. The sampling data or sampling mechanism is baked into it. Yeah. Our version of it is because you send it into a Scribe queue, so it's completely asynchronous. And the way Scribe, I don't know if you know Scribe very well, but Scribe sits on every host, so you just send it to a local host, and then Scribe kind of handles aggregation and sending that off. You could send it directly into the Zipkin collectors if you wanted to. I wouldn't suggest it unless you have a very small architecture. But yeah, that's it.
Okay, thanks.
Yeah. The question, for anybody who didn't hear, the question that answered was, is Zipkin's collector architecture asynchronous? Yes. Even if you don't have like this giant architecture that you want to see traced all through there, even if you have just a couple of services or something like that, I think this is really helpful because you get, like I said, you get per request statistics or per request information, obviously downsampled. So that can be pretty helpful, I think. Sure. So the question was, which storage works best? Like anything engineering, that's sort of specific to your architecture, obviously. Cassandra worked really well for us for a long time because it's very good at taking on writes, but reads were hard. We use Manhattan internally because we're trying to shift most of our architecture over to Manhattan. Manhattan's kind of becoming our like Google Bigtable a little bit, like our de facto storage. So it just sort of, and we're trying to decommission most of our Cassandra clusters internally. So that's the shift for that. There are a few HBase cases out there. Like HBase was an external contribution. So obviously at least one person or one company is using HBase. I think a couple are. And then Redis was the same thing. Somebody else wanted to use Redis as the storage layer. For whatever reason, they felt Redis was best for their architecture. So yeah, the short answer to that is obviously it's like trade-offs depending on your architecture. Do we age out data? Yes, absolutely. Right now, we have a TTL on our main spans. If you look at the way Cassandra is set up, Manhattan's set up very similarly, in that we store our spans by trace ID, and then we store indexes to those trace IDs based on service names, annotations, that sort of thing, so you can search on all of those things. Our indexes die after 3 days, and our main spans have a TTL of a week right now, and that's plenty. For the most part, if people really want the information right now, they send a debug trace through the system, and then they have it immediately, and they can see what's going on. Thanks, guys.